Okay, ladies and gentlemen, what we're asked to do in this problem is using our graphing calculator. Well, that's kind of obvious because we sure wouldn't know what that graph looks like without it. But using our graphing calculator, graph this function and then tell where the function is increasing, decreasing, and what the relative maximum or minimum of the function are. Well, to graph this function in my graphing calculator, a very important thing to note is when you're typing it into your calculator, x squared plus 1 is one entire grouping. And when you enter this into your calculator, it is essential that you build in those parens on your own. So, for example, okay, when I get ready to put this into my calculator, come over with me to the calculator here. Let me turn it on. Okay, on. And I'm going to hit zoom 6, standard window, y equals, and I'm going to type in this function. So the top would be, the numerator would be 6x, okay, and then divided by, but here's the key, left paren, see, you've got to put this in symbols, left paren, x caret 2, that's x squared, plus 1, close paren. So this is the correct way to enter it into your calculator, and now we hit graph. So we have a function that looks like this, okay? And roughly, if I trace that to my paper, okay, it comes very close to the x-axis, never touches it though, comes down to a little valley, passes through the origin, comes up to a hill, and then comes back down here. Okay, now what's happening in both of these directions is the graph is asymptotic, A-S-Y-M-P-T-O-T-I-C. The graph is asymptotic to the x-axis. What that means is it's getting closer and closer to it, but it never, after a certain point, it just never is going to touch it again. It's just going to hover close to it. As it goes out in this direction, it goes out in this direction. Now, what we're interested in mainly right now is we're interested in this hill and we're interested in the valley. So, let's try to find the hill first. So to do that, I'm going to hit second function calculate. Okay, let me try it again. Second function, let me try it again. Second function, trace, there we go. Now I'm to the right menu. And so I got there by hitting second function trace, and I'm going to pick option 4 for maximum. And what I'm going to do is I'm going to set my left bound. So right now there's a good left bound. I'm to the left of the hill. Right bound, I'm going to use my arrow key, and I'm going to move my spider, my dead bug, to the right of the hill and hit enter. And then I'm going to go to the top of the hill and hit enter. And I come out with a minimum value of, and let's be reasonable, how about just calling it the ordered pair 1, 3? Okay? So, we're going to call this 1, 3. Now by symmetry, or we could also go back to the calculator and use the minimum to find this point, but by the symmetry of this graph, if this is the ordered pair 1, 3, this is going to be the ordered pair -1, -3. And that's just by symmetry, okay? But again, if you feel better using your calculator and doing minimum, you're going to get that same answer. Now, the relative maximum value and the relative minimum value, the relative max is going to be the y value at the top of any hill. Well, this is our only hill, and the y value here is 3. So our relative maximum value is 3. Relative minimum is the y value at the bottom of a valley, and the only valley we have is this one, and the y value there is -3. Okay, the last things I need to know, where this graph is increasing and where it's decreasing. And remember, the way I do increasing and decreasing is I draw in these little dotted vertical lines where the graph is changing direction. Okay? This part of the graph is dropping. This portion of the graph is rising, it's increasing, and this part of the graph is dropping. So when I look along the x-axis and I want to see where this first piece is, I'm coming from -infinity to -1. We use the x value. This x value is -1. This x value is +1. So -infinity to 1, the graph is decreasing. From -infinity to -1, the graph is decreasing. And again, no bracket. Between these two values, the graph is increasing. So between -1 and +1, the graph is increasing. And here, from 1 to +infinity, the graph is decreasing again. So we put union 1 to infinity. And that takes care of that problem. Most important thing in this problem to remember is to enter it correctly. And we're done.